Hey Geometry, Miss Soli here with 3.3, the third type of transformations. This one is called rotations. Whoa. So reflection, you're flipping one thing over a line. Translation is more of a slide. You're taking this whole shape and it's sliding over here. Rotation is where you're going to turn an object about a point. Oops, 3.3, rotation. So a rotation, you need two things, like two pieces of information to be able to do the rotation. You need where it's being rotated around and what angle of rotation do we have. So it might look something like this. Here, I'm going to say rotation is a turn about a point. So say I had here point A, and I have a P. This could be the point or center of rotation. And so I've got my point P here, and notice that I could attach these, I guess, with like a straight line. And think about, like, let's say I had this dotted line here was a string, and I'm holding it still here, and I can rotate it around this point, just kind of by spinning it like this. And then let's say I've got up here my image. This is my pre-image. And my image, A prime. And this now, this point was turned about that center of rotation. So when that happened, these two lines are congruent. They're the same. It didn't change the length of that. But what it did was it just turned at a certain angle. Turned at a certain angle. And your symbols for this looks like this: a lowercase r. Remember that reflection also starts with an R, and we had an uppercase when I'm looking at a reflection. Rotation is going to be lowercase, and then in parentheses, at what degrees and what point was it rotated about. Whatever pre-image is equal to your image. So this one says rotation. This one is the angle of rotation. And then this here is going to be the center of rotation. Center or point of rotation. And these ones always are going to be the same here. Your image, your pre-image, and your image. Okay. Now, most common rotations you're going to use are rotations of 90 degrees, 180, 270, because they're shifting it like a quarter of a full circle. And those ones you can kind of do with no extra tools. So let's take a look at those three. To rotate by 90 degrees. So this would look like this. If I have a graph here, let's say I have a point right here, and I was rotating about the origin. Now, origin is the point 0, 0, and it's kind of the most common point to rotate around. So instead of like writing out 0, 0, shortcut for the origin is just a big O, which is tricky because it looks like a 0, but it's an O for origin, 0, 0. All right, so say I have this point here. This is my image. This is the point X, Y. If I were to rotate it about the origin, so I'm going to like find this line here, right? And that's the point X, Y. And I turn it 90 degrees. These two lines are equal. And I find here my image. This point now is going to have the same numbers as X and Y, but a little flipped and reversed. So notice my first, I mean, you can think about it in terms of slope. Like I went over X and up Y. So now I'm going over Y and up X. So this point becomes negative X, negative Y, X. And if we write this all the way out, like in the symbols, reflection of 90 degrees about the origin, what it will do is take your xy and become negative yx. So you don't have to do any math. You don't have to do any like calculations to try to figure that out. You're just switching the places of it and the y turns negative. Now let's do the same thing with 180 degrees. So that one will look like this. I'm going to actually have the same A as best I can here. X, Y. And about the origin. So here's my line. And to rotate 90 degrees, that's to make a straight line, yeah? There. And so this has rotated 180 degrees about the origin. So here's my new image. The reflection of 180 degrees about the origin is your xy becomes, so I went over x up y, now I'm going to go to the left x and down y. Negative x, negative y. And then the last one, 270, the last kind of shortcut one where it doesn't change the values. 270 about the origin. So that would look something like this. I'm going to start with my same xy at point A. And this one 270. So I'm going to go 180 and then another. So it looks like there's a 90 degree here, I guess. Because it's just 90 short of 90 short of a full circle of 360. And in this case, this one went over x, up y. It's going to go over y and down x. Like that. So a rotation of 270 about the origin of xy is going to give you y negative x. Shortcuts. Now, there's a whole lot more angles than just 90, 180, and 270. So what if I ask something like, rotate this point, rotate point A 75 degrees. What if I asked for something random about point B? P. Let's make it P just to keep it consistent. So let's say here's A, here's P, and I want to rotate 75 degrees. Now, that's almost 90, but it's like not quite. In order to do this, we need an extra tool or two. This is called a protractor. So it has all of the angles between 0 and 180. And what you would do is put an angle of 0 degrees, like centered on the point P, and 0 degrees at A here, and then map out all the way till 75. So it looks like 75 is, whoa, right at the edge, right there. So, and then I also need a ruler, which I do not have here. Let's see. We'll make one out of a Post-it. So a ruler just needs to know to space these out evenly. So if this is A, this is P. This is my line segment there. So if I were to continue this P in this direction, it would end up right there. There's your image. So here to here, those two lines are equal, and this did rotate by 75 degrees. Now, I recognize that not everybody has a protractor, and so when I'm asking you questions about a certain angle measure online, it'll have like a pop-up protractor to use. But you don't need to use one in your notebook. Just kind of give it a good estimate. We'll write down this is the tool you need. A protractor and a ruler. Because the protractor turned the angle, and then the ruler made the two line segments the same for the length.